In economic theory, there are two things that we try to do when we evaluate people's behavior. There's two primary methods of analysis. One is called optimization, where we try to optimize something, where we try to either maximize a benefit or minimize a cost within a constraint. And we'll be talking about that further into the class. Another option, another alternative, is to do what's called an equilibrium analysis. Now, most of you should be comfortable or familiar with the equilibrium analysis. This is sort of a classic example of demand equaling supply. So we have two curves, and we find a point where those two things are equal, such as the traditional demand and supply curve that we see here. In this case, we have a quantity, we have a price, we have a downward sloping demand curve and an upward sloping supply curve. And where those two lines intersect, we have an equilibrium, where we find the price and the quantity that clear the market. And this clearing of the market is a good thing, because what happens is that at this price, there's no excess demand and there's no excess supply. All of the interests of the buyers and the sellers come together, the market clears, and this is a really good thing. Now, when we are analyzing this set of this approach, when we look at an equilibrium analysis, this assumes a lot about the markets. It assumes that things are going to stay constant, that they're going to stay steady, but they don't have to. Obviously, in a market, things begin to change. And a comparative static analysis is a way of illustrating those changes, illustrating a change in the equilibrium point when circumstances within an economy changes. So we've got our traditional example of when the demand curve shifts or the supply curve shifts, and it causes one of these two curves to move to a different location. So for example, if this is the market that we're living in, and we have a shift in the demand, let's say demand increases, then we go from the black demand curve to the red demand curve. If the supply curve stays the same, then our new equilibrium occurs right here, and our new equilibrium price is higher, and our equilibrium quantity is also higher. That's a comparative static analysis, where we compare two static or two equilibrium points in a market. And if the curves change, that leads us to a new equilibrium point. Now, this is something that we cover in principles all the time. However, when we get to the intermediate level, we tend to use a little bit more math in our analysis. So let's take a look at a situation where we're trying to find an equilibrium using some basic math. We'll get rid of our graphs here. And let's say that we have a demand curve that takes the function, or takes the form of this. We have QD is equal to 1,000 minus 200p. This is just a linear equation. And if our supply looks like, let's say it looks like this, so just a basic setup, what we want to do is we want to find what's the equilibrium price and the equilibrium quantity for this equation. Well, that's a pretty simple algebraic problem that we now have. Because in equilibrium, remember that the quantity demanded up here and the quantity supplied here are going to be equal to each other. So what we do is we just assume that these two values, the quantity values, are the same, and we set these two equations equal to each other like this. So the demand, 1,000 minus 200p, is going to be equal to 800p, which is the supply. And we just solve for p. So in this case, what we would do is we would take all of these p's over to this one side, and we'd be left with 1,000 here, basically adding 200p to each side. So this side, that would cancel out, leaving us with 1,000, equal to 800 plus 200 would give us 1,000p, which means if we divide through each side by 1,000, we have 1 equal to p. That's the price for this product. And so we take that price and we drop it back into either one of our quantity equations, and we should get the equilibrium quantity, and it shouldn't matter. So if we put 1 in here, then what we have is a quantity supplied equal to 800 times 1, or just 800. If we put the 1 up here, we end up with 1,000 minus 200 times 1, which also equals 800. So the mathematics behind the equilibrium condition, at least in the demand and supply model, the market model, is we have an equation for each line, we set them equal to each other, and we solve for the equilibrium price and quantity.